Hello there. Let's talk about directories in Linux. And you know what? There's a spoiler here. Directories are folders. Nothing special, actually. In fact, directories are the correct name for the thing that we use to hold all of our files together. So you might be wondering, so why do we call them folders then if they've always been called directories? Well, when the first graphical user interfaces were being created, we needed a way to visualize the thing that organizes files. And if our files are like the paperwork that we deal with, well then the directories are like the folders we keep our paperwork in. Now, yes, this is what we're going to be talking about in this video. How Linux handles folders. Now get used to me saying directories because I'm probably going to say that more often than I say folders. Now please don't close the video. Let me explain a bit and you'll understand the importance of all of this. So one of my many hot tips when it comes to Linux is Linux treats pretty much everything as a file, which means that being able to manage and organize files is crucial. And therefore, being able to handle the directories is absolutely paramount. Now, when I say Linux treats everything as a file, files are files, obviously. Directories technically are files that hold other files. Programs are just files that execute. And even our hardware in Linux gets represented as a file. So believe you me, anything to do with managing files and directories as well is absolutely important. Even managing configuration in Linux can be as simple as going and making an edit to an ordinary text file. So let's go and get comfortable with Linux and how its directories work. First up, let's have a look at a directory path. Something like /home, /bob, /documents. So the way you want to look at a directory path like that and interpret it is the first / is the root directory, which is the beginning of the directory or folder structure. The second / onwards, these are directory separators or delimiters as they're better known. And the home, the bob, and the documents portions, those are the directory and subdirectory names. So what we're looking at is under the beginning of the file system or directory structure, we have got home as a directory. Within that, we've got another directory called bob. And within the bob directory, we have documents. This is very similar to what you would come across in other operating systems like Windows. For instance, in Windows, you have /users / somebody's name / documents. Now the thing is, unlike Windows, Linux doesn't use a drive letter. That drive letter that you see in Windows, that C:, that D:, that E: stuff, that is how Windows takes a storage disk and mounts it and makes it available for us to work with. Now Linux doesn't do that. What Linux does is all storage locations are mounted under one file system and directory structure. My second, my third, my fourth hard drive, and even external media can all be put under the root directory somewhere. Which means I don't sit there going, ooh, which drive is this folder on? Or which drive is this file on? That's what we have to deal with in Windows. In Linux, it's like just which directory did I mount that disk under? Now, storage disks themselves do get a letter to identify them in the /dev directory, so I can distinguish the first drive from the second drive from the third drive. But in terms of accessing the directories and the files on them, there's no drive letter to mount them and make them available to my file manager or my command line when I want to navigate and work with it. Now, another thing that you also want to know about when it comes to the Linux directory paths, and technically also the file names, is that in the command line, Linux doesn't like spaces in names. Now, the reason why is because in the Linux command line interface, the space is seen as a separator to differentiate between the command and the options that we apply to the command and the things we want the command to work on. So, if you do have a directory name or even a file name with spaces in it, it'll either be typed within a double quote, so double quote a name with spaces, or it'll be the name / space with / space spaces. Now, those backslashes there, Linux treats the backslash character as an escape character. Now, an escape character in Linux means don't treat the next symbol like you normally do. Do something else. So, like I said just now, Linux treats the space as a separator, normally between different files or different directories we want to work with. And in the commands, it'll be a separator between the command and the options and the things we want it to work with. Now, when I do a backslash, it says just treat it as a space. So this is how you would see a directory or a file's name with spaces in the command line. Now, I warn you about this because if you play around with your directories and files in the graphical user interface in Linux, most of the GUIs or desktop environments, as they're correctly known, tend to allow you to have spaces in these things' names. Which leads me on to another useful hot tip. When it comes to naming conventions in Linux, another thing you want to know about is that Linux is case sensitive. And when I say it's case sensitive in all ways. You've got to watch how you type your commands, you've got to be mindful of the names you give things, and mindful of the options you're using in the commands. Because Linux doesn't see the capital A and the lowercase a as the same character. You and I recognize that as, hey, it's the same letter, it's just uppercase versus lowercase. But in Linux, it sees it as two completely separate characters, which means if I give something a name, and I do a capital N on the first thing's name, and a lowercase n on the second thing's name, Linux will treat that as two separate things. If you try that in Windows, for instance, Windows will tell you, sorry, that name of either a directory, folder for Windows, or file already exists and offers to give you a different name. And this applies everywhere. The directory names, the file names, and most importantly, the commands and the options. The commands will normally throw an error if you type them incorrectly, but with some of the commands, the same letter with a different case can do completely different things when it's used as an option. I will remind you of this when we start playing around with the commands that have some interesting options. Now, let's look at standard directories in Linux. Basically, you want to get familiar with what directories or folders already exist on a standard Linux machine. Now, what I'm about to show you is required to be considered a Linux machine. When you play around with whatever distribution of Linux you prefer using, you will find you might have other directories present. So, it all starts with the / or the root directory, under which you have all of these bad boys. You've got a directory called etc, a directory called boot, another one called bin, another one called sbin, lib, usr, home, root, var, tmp, mnt, media, dev, and run. And please note they are all lowercase in their names. So as we said already, the / is the root directory, or the beginning of a directory path, file system, folder structure, however you want to see this. It's sort of like the C:\/ you have in Windows. Now, let's get a good idea about what you will find in these directories. etc is a directory you'll get more and more familiar with as you do more and more Linux administration things, as etc is where you will find your text configuration files. And anything you want to set up and configure in Linux has a text file somewhere in that directory, possibly some subdirectories, and you can either use a command to go and affect the change in configuration you want to, or you can go and use a text editor and manually edit the file. Then you've got your boot directory, which, as the name implies, contains your boot files and the kernel, the initialization RAM disk or init.rd file, boot configuration, etc. If it's necessary for Linux to boot up, you'll find it under the boot directory. Then you have the bin directory or binary directory. Now, this will help you out a little bit. An old Unix name, which got carried forward into Linux, or a program or application, is a binary. Effectively, a binary is an executable. So the bin directory is now easy to remember. Bin, binary, it's the executable, it's the programs we run. Now, these will be program files that you will find under the bin directory required for normal operations. Whereas sbin is used for storing executables and programs for system operations. One of the ways I remember the SBIN and the system operations is usually you need some sort of privilege. And when you need to give commands privilege in Linux, you normally put the sudo, S-U-D-O, before it. Sudo gives you admin rights in Linux. SBIN stuff often needs admin rights to run properly. Then we have the lib or the library directory. The library directory in Linux contains shared resources for programs. So it'll contain things like programming libraries, and Linux is equivalent of DLLs basically, things that can be shared between different applications and services. Then you get your USR directory. This contains programs and resources that we want to grant user access to. Basically, it's the type of stuff that people will want to have access to after Linux is finished booting. And quite often you'll see a lot of the applications and packages you want to install, run, and use, which then become the commands that you run normally, will normally be present somewhere under USR. So you actually have a USR bin, a USR SBIN subdirectory. You'll also get a USR local bin and a USR local SBIN subdirectory path as well, all of which can contain the executables you want to run. Then you've got the home directory, literally called home, and that is where all of the users will have their own subdirectory, usually with their username. And within those will be that person's documents, their pictures, their desktop, stuff like that. And then you get a directory called root, R-O-O-T, and that is the root user's home directory. The root user in Linux is the default local administrator account, and that user has their own home directory that is not under /home. It's kept elsewhere just to keep all of that isolated, so it makes it a bit harder for a standard user in Linux to accidentally access anything administrative. Then we got the var directory, which contains files that are expected to change or vary on their own. A good example of that would be log files. This is a directory that will allow for software services to easily come and make edits to it. So we cannot expect those files to be consistent, but that's fine. Because I don't know about you, but I want my files to change in the background if they're going to hold logs and stuff like that. We also have the TMP directory, which is another directory that allows for files to change without our knowledge. And the TMP directory is for temporary files that might be used by the programs we're using. A good example would be the cookies that your web browser downloads, so that the various marketing companies can track you and serve you targeted advertising, much like this advert that you're about to see now. MNT, or the traditional mounting directory, is where older Unix and fairly early Linux systems would normally add secondary storage. But more modern distros tend to prefer mounting removable storage under the /media directory. MNT is just kept around for backwards compatibility and legacy compatibility support, especially if maybe you've installed a package that hasn't been updated for a long time and still wants to use MNT for something. So even though media has come along and it's a much easier and sensible place, we still have MNT just for the old-fashioned reasons. The dev directory is the directory where all of our hardware devices will appear as text files. Finally, the run directory will hold running information about the system. Usually it'll contain extra details about the hardware and how we are using it. So for instance, I could see maybe some parameters and details about how my CPU is being used by the operating system. So that's quite cool to know and definitely worth getting familiar with. But now let's talk about how we can work with these directories. And the first thing we need to be comfortable with is how to navigate them. So one of the first commands that you want to know is the ls command. Now, in Unix and Linux, but obviously Linux because that's what we're focusing on here, most of your commands are either going to be acronyms or abbreviations to make it easier and quicker to type. So if you can remember what the command is for or what its name means, it'll help you remember the command a lot more easily. And ls is meant to be short for list contents of directory. And when we run it, what it's going to do is it's going to show me the files and directories that are present wherever I am in my file system. Now, if I run this command on its own without an argument, in other words, something I want the command to work on, it'll just show me the contents of the present working directory that I am currently in. But I can type after the ls command a directory as an argument, and what ls will do then is it'll show me the contents of the directory that I typed there without me having to go and navigate in there with a cd command, which we'll talk about just now. Now, there are options as well that we can use with the ls command. One of my personal favorites is the -l option for the long list formatting. And you know what? Let me show you why I like the long list formatting. So let's hop onto one of my Linux machines and open a terminal. You can either go and navigate through your application menu launcher for a terminal, or you can just use keyboard shortcuts like Control, Alt, and T, and you'll get a terminal window open. So, like I said, you can run ls, and that will show you the contents of the current directory you're in. Normally when you open a terminal in Linux, you are in your home directory. So what we're seeing there are the subdirectories that I have. My desktop directory, my documents directory, my downloads, my music, my pictures, my public, my templates, and my videos. Neat. But we can tell the ls command to go and show me the contents of another directory without me having to go there. So I could say to the terminal ls /etc, and that'll show me the contents of the etc directory. And as you can see, we've got quite a lot of files and directories here. Some of them are even links, or the Linux equivalent of shortcuts. Now, how do I know that? Well, the reason why I know that is I'm familiar with how, in this case, Linux Mint does text formatting in its terminal application. But for you guys, while you're learning this and getting comfortable with this, let's use the long list, and I'll show you how to recognize whether something is a file or a directory. So let me tidy up my command line first by just typing clear, and that just clears any output that's on the screen. And let me type ls-l, or long list format, space, /etc. Notice how I'm putting a space between the command and the option and the argument. This is the reason why Linux doesn't like spaces in file names and directory names, because Linux uses that space to know, oh, you're done typing the command, now you're typing the option. Oh, you're done typing your options, now you're typing arguments, or the thing you want me to run this command on. So when I run it now, I get a slightly different output. Now, if I'm being perfectly honest with you, the reason why I like the long list format is instead of showing me things left to right, top to bottom, all of my items are now vertically arranged here in alphabetical order. So it's a little bit easier for me to read. But you do you. Now we get a bunch of extra information here about these things. First of all, we've got a perfect option here. We've got something that has a D as the first character right over there. When this little cluster of permissions and attributes begins with the letter D, it means that thing is a directory. If it begins with a dash, it means that thing that we're looking at is a file. So now you can see that when the text is white and no special effects are applied, that's Linux Mint showing me, hey, this is a file. And when it's bolded with that dark blue color, it's telling me, hey, that's a directory. Cool. Then the next 9 things that come afterwards, those are the permissions that are applied to that file or directory. And it's a cluster of RWX, or read, write, and execute. And if you're missing one of those 3 permissions, or all of them, there'll be a dash there instead. We'll talk more about those when we do a later video about permissions and security. Then, these numbers I'll tell you about later on in this course, when we do things like links and all of that. Then we're seeing the name root. That is the name of the user that owns this file or directory or whatever the object is. Then you see the name again, and that is the name of the group that owns this directory or file or whatever. And yes, a lot of users also get a group that has their name. Like, for example, here's the root user, here's the root users group. The next item is the thing's size in bytes. So your directories usually get listed as 4096 bytes. And then the other numbers will obviously be the actual file size. So for example, my pam.conf file is 552 bytes big. Then you'll get a date and possibly a time. If not a time, it'll be a year. And that is the date and time of the file's last modification. Finally, the thing's name. So quite a nice output. Besides the long list format option giving me this information in a way I prefer reading it, it also gives me a whole lot of extra information I'm probably going to want to know next. So let's try the long list option on my home directory quickly. Now I can just say ls-l and press enter and get my home directory. Or I could say ls-l /home dbt. That's the username I chose for myself here. It'll work the same either way. And as you can see, all I have in my home directory at the moment is just directories. And you can see the permissions, you can see the username that owns it, the group name that owns it, the size, and the date and time it was last modified, which is the date and time I installed this. Now, I am going to go on more about the ls command and some extra options for it when we start doing how to work with our files. And that'll probably be the next video we do. But let's carry on with how we can navigate our directories. pwd, or present working directory. This is a very useful command to run, as it allows me to check very quickly and very easily which directory I am sitting in. So back on my VM, if I type pwd, it tells me, I am in /home/my username. I can tell that because my Linux Mint VM's prompt gives me a little bit of extra information. That's my username, at my host name, colon, and that little squiggly line, or the tilde symbol. That indicates the name of the directory I'm in, and the little tilde symbol is used as shorthand for /home/whatever my username is, or the user I'm currently signed in as. Otherwise, it would have to print /home/dbt for me. They might think, well, then why do I need the pwd command? Not every distro is going to give you the current working directory in the prompt, like my one is right now. Maybe I'm remoting in through a terminal emulator. Again, I might not get that with my terminal emulator. So it's always good to be able to check which directory you're in, especially when you're moving around a lot, because you might lose track of which one you're in. Now to move around, you're going to use the cd command. Now the cd command usually takes an argument, and cd is short for change directory, not compact disk. Those are old and outdated. But changing directory, that is still modern and relevant. So if you type cd on its own, it'll take you to your home directory straight away, or whatever user you're logged in as. Ideally, you should be logged in as yourself. You can also type cd with the tilde symbol as an argument, because remember what I just told you, the tilde symbol, or the squiggly line, is shorthand for /home/whatever your username is. And then if you type anything else, any other directory path, cd will take you there. So if we type cd /var/log, it takes me to the subdirectory under the variable directory where the log files are kept. So let's go and check that out. So if I say cd /var/log, it takes me there. Now again, my Linux Mint machine has been quite cool and showing me my current directory in the prompt, but I can still say pwd just to double check myself. And even if you are getting comfortable and familiar on a distro that does this like mine is, where it shows you the current working directory in the prompt, please do me a favor, get in the habit of running pwd regularly just to double check where you're at. That way, when you're working on a Linux distro that doesn't do this, then you've got it on hand for yourself. I can also say cd /etc and go to where I want to be. You don't have to keep going back to your home directory or anything like that. But if I want to quickly get back to my home directory, I can just say cd on its own, and voila, I'm back to my home directory. Nice and quick. The reason why Linux tries to keep the commands and options as short as possible is to keep the amount of typing you have to do to a minimum. Which brings us to the next point, and that is that commands like cd can use either absolute or relative paths in the directory path name. Now, an absolute path is where you've typed the absolute full path from the root directory all the way to the destination. So for example, I could say /home, /bob, /documents, /homework with something like the cd command. And what that'll do is it'll definitely take me to the homework subdirectory in documents in Bob's user's home directory. And this will work no matter where I am in my directory structure. I could be currently sitting in /home/bob, or I could currently be sitting under /var/log, and it'll take me there. But that can be a lot of typing, especially if I'm already in the Bob user directory. So that's where relative paths come in. And with a relative path, it's assuming and working with where you currently are, what's your present working directory, and then you just have to type the rest of the directory path. So for example, Bob is currently sitting on their home directory, /home/bob, and they want to navigate to their homework directory. So they could just say cd documents/homework instead of typing out that whole long path. Now, I'm not Bob, but what I can at least do is go somewhere else. So you can all agree that I am now sitting under /var/log. Now I can say cd /home /dbt /documents with a capital D. And that straight away takes me into my documents directory. No hassle, no trouble. And I wasn't even in my home directory. But it's not overly impressive, because I could also be sitting in my home directory. I could type the same thing. Let me use the up arrow key to bring the previous command back. Most Linux distributions have command history enabled by default, so you can use your up and down arrow keys to cycle through your previously entered commands. Very useful if you want to run the same command again, or you want to run a variation of an existing command. So cd home dbt documents, it also works in my home directory. That's the beauty of an absolute path. It's the full path. So it'll always take me where I want to go, no matter where I currently am. But it can be a little bit of extra unnecessary typing sometimes. Now let's do the relative path. I'm currently sitting in /home/dbt. So typing this portion is kind of redundant when I'm already partway there. So I can just say cd documents and I'm there. Works wonders. But if we go back to the var log subdirectory and I try and do cd documents again, it doesn't work. It says here bash cd error documents, no such file or directory. And the reason why is because under /var/logs, there is no directory or file called documents. This is the power of the absolute path. Doesn't matter where I am, it will take me where I want to go. But the relative path only works when I'm already partway through that directory path, when I'm sort of already in one of the parent directory locations. Use both to your advantage. If you already know you're somewhere along the directory path, use the relative path. But if you want to be precise and certain, etc., use the absolute path. It is a bit of extra typing, but it's not that bad. Because here's another little tip for you. I was getting some of those names typed really quickly. And the reason why is once I've typed enough of something for Linux to know what I'm up to, I can press the tab key and Linux will auto-complete it for me. If I haven't typed enough for Linux to be sure, I press tab twice, because it probably won't work the first time, and on the second tap of the tab key, it will show me the options and possibilities. So what I've been doing, and the way I got the word documents typed so quickly, was I typed DOC, capital D, and I pressed tab, and it auto-completed the rest for me. Absolutely lovely quality of life feature. Now, navigating our directories is all well and good, but let's talk about making and breaking. So we want to create a directory. We're going to use the mkdir command, or make directory. Now, you can either use absolute or relative paths to create or make new directories. But we also sometimes want to get rid of directories. So because of that, you want to know about the rmdir command, which you might already have taken a decent guess at, is short for remove directory. Now, the remove directory command is quite interesting. It will fail if the directory is not empty. The Linux command line is going to try and protect you from yourself by not allowing you to delete or remove a directory that does have stuff in it. The reason why is when you delete files in the command line with Linux, there's no recycle bin, there's no trash can, there's no quick undo. Linux assumes when you're doing stuff in the command line, you know what you're up to. So it's actually nice that the rmdir command will go, hey, this thing is not empty, you sure you want to get rid of it? But you can tell it to skip the check with the -- ignore -fail -on -non -empty option. There is no short single letter option for that. And the reason why is to make sure that if you're going to tell the rmdir command to not warn you if the directory has contents, you're going to be doing this very intentionally. But we can actually also use the rm command, which is the remove file command normally. Now, if I just say rm and a directory name, it usually will give you an error about this is not a file, this is a directory. But you could use rm-r to tell it to actually remove a directory. The -r option is actually short for recursive. Now, whenever we have a command in Linux that's got a recursive option, what it's doing is it's telling that command, hey, if you're about to work on a directory, go into the directory, do your thing, and then step out, and you can then do your thing to the directory. And it actually works out pretty well. Let me show you. So let's quickly cd back to my home directory and clear the screen. So you can all agree I'm in my home directory. And those are the subdirectories we currently have. Let's do mkdir docbird. And now if I do an ls, I've got a docbird directory. Now I could either cd into the docbird directory and mkdir tech. That will work. But that's not so much fun. Let's take advantage of the fact that the mkdir command works with absolute and relative paths. In other words, I could do this. I could be sitting in my home directory and I could say mkdir docbird /tech. And if I ls the docbird directory, it shows me that I've got tech in there. I'll prove it even. cd into docbird. The docbird desktop documents and downloads appeared because I didn't type DA before I pressed the tab key. Now ls, there's tech. Fantastic. So we've got mkdir where we can do really cool things like that. Now if I cd back to my home directory and I want to remove that directory, let's say I say rmdir docbird. That's the error I warned you about. If a directory you're trying to rm with the rmdir command has something in it, it'll give you an error to try and protect you from deleting something by accident. Now I can either go into that directory, rm or rmdir what is currently in there, and that didn't fail because the tech directory has nothing in it. Then I can cd out of it, and rmdir docbird tech, and it's gone. Now let me quickly bring it back. Okay, sorry, I just quickly reran the commands to recreate docbird directory and the tech directory. Because now I want to show you how you can use the rm-r command to do that a little bit quicker. The reason why I want to show you the rm-r command is if you're really sure you want to delete a directory and all of its contents and subdirectories, rm-r is a lot easier and quicker to type than rmdir space -- ignore -fail -on -non -empty space and the directory's name. So let's rm my directory and it throws an error. rm cannot remove this, it is a directory because rm is designed to delete or remove a file. But if I tell rm to work recursively with the rm-r option, it didn't give me an error this time. If we check, the Darkbird directory is gone, and therefore the tech directory inside of it must also be gone as well. Notice how with a lot of the commands in Linux, it doesn't always give you feedback. It assumes that you're happy, you know Linux did what it was meant to do. Linux assumes you know what you are up to. Bit of a dangerous assumption, but hey, that's why you're here, right? So that we can try and make sure you know what you're up to. And also, why I want you to play around in a safe lab environment of your choosing. Go check out some of my previous videos in this series if you want to see options for building a safe lab environment. But that should be a decent intro to Linux's directories and moving around them. Plus, I gave you some cool tips and demonstrations on how to work with the commands a bit. Now, in the next few videos, we're going to start playing around with just playing with files and how to work with them. And then we're going to start moving on to more interesting things. But the nice thing is, we're going to get a lot of cool opportunities to see how the commands behave and what the options look like. And you're going to develop more familiarity with all of this. Now, one of the cool things you can do to follow along is if you have bought yourself or got yourself some sort of lab environment where you can play around, you can try some of these things that you've seen me doing in this video yourself, because watching me is great, but trying it out for yourself is when you really start to internalize and learn this stuff. But otherwise, I'd love to say thank you for watching. I really appreciate it. And if you have anybody that you know that would like to learn Linux like this, don't be afraid to share this video with them. But otherwise, I'll catch you in the next video.